Good afternoon, everyone, and welcome to my YouTube channel. So here today we are going to be proving whether or not this is an irrational number. So we have the square root of 2 is irrational, so this is type 2. We have already done type 1. Prove that the square root of 2 plus 3 is also irrational. So how do you prove this one? So you are going to prove by method of contradiction. So you are going to say suppose the given value, which is our square root of 2 plus 3, is rational. So we have to first prove, since we are using method of contradiction. Suppose square root of 2 plus 3 is rational, then we can say then it can be expressed in the form A over B. So rational numbers can be expressed in this form. Then we are going to say where our A and B are elements of Z. So Z means the integers, numbers, negatives and positives. That does not include fractions. So now, with that said, we also have and our B, which is the denominator, should not be equal to 0, because if you have A over 0, it will be undefined. You cannot evaluate the value of that. So therefore, it should not be equal to 0. So when you make this assumption, it means that you can equate this to A over B. So we are going to say that the square root of 2 plus our 3 should be equal to A over B, like that. So under this one, we don't square both sides, but we just leave the square root alone. So we have the square root of 2 should be equal to A over our B. Then we have minus our 3, like that. Then what we are going to do is we have the square root of 2 should be equal to our B is our common denominator. So we have our A minus our B. B divided by 1 is B times 3. It will be 3B. So we have our square root of our 2 should be equal to A minus 3B over B. Remember, we were saying that our A and B are part of integers. So integers include numbers such as -1, 0, 1, 2. It does not include fractions. So now, if you have that type of a situation, whatever A and B is equal to, it will always give you an integer. Like for example, if you get let's say your A is equal to 1, then your B is equal to 2. If you were to replace this, we are going to have a certain situation such as our A is equal to 1, so we have 1 minus our 3, where there is B we put 2. So already 1 minus 3 times 2 is 6, so 1 minus 6 will give us a -5. Now this -5 is an integer. Now if you put over your B, which is a 2 there, it will be a 2 there. So this number -5 over 2, this is a rational number. So in other words, as long as you have an integer on top and an integer down, so already this whole thing will always give you an integer. So this will give you an integer as long as your B is not equal to 0, because that would make the equation undefined. So now look, this is an integer, this is an integer. So if you divide an integer over another integer, it will give you especially in this way, it will give you a rational number. So already this means that if we have the integer there, it will give us a rational number. So now we begin our contradiction from here. So this is how we come up with a contradiction. We can say that we know they have given us that the square root of 2 is irrational. But our A minus our 3B over B is rational. So this is a rational number. Then we can say therefore our A, so already there is a contradiction. This one is irrational, this other side that is rational. So we can say therefore it is a contradiction. So we can say contradiction as a rational cannot equal an irrational. So now we already know to say the value they gave us, which we know is the square root of 2, is irrational. So you can say therefore the square root of 2 plus 3 is also irrational. So that is how we go about that in type 2. Thank you very much for watching. If you enjoyed the video, kindly like, subscribe and share for more.